Hello and welcome back. Well, we're going to put this Sprag bearing or Sprag clutch differential in, and it's going to be a big job. We've got a lot of modifications to make. I'm going to do a little more than just put this in. Part of it is making this fit. There's not quite enough room for it. But anyway, let me show you what we're going to do. This differential, the axles are going to go into where these bolts go, and it'll sit right in here. These right here will be removed. I got to take the drive frame out and cut these off. And I got to move the motor back about, half an inch to an inch. And I got some rubber grommets I'm going to put between the wood and this frame, hopefully to suppress some vibration. It's not excessive, but it is annoying amount of vibration. I do have rubber right there on the engine mounts, and that helped a lot, but now the engine tends to tip a little bit when you accelerate, and changes the chain alignment and also puts slack in the chain. And I ended up putting this spring-loaded chain tensioner in here. That's what this spring is right here. It's an arm that pushes down on the sprocket, or on the chain. And it's really tight in there, but it works good. But I'd like to improve on that a little bit. And then right here, I'm going to weld this in here on the bottom of the motor mount plate. Right there. Just barely clears the sprocket. And I'm going to have support bolts that go down to the drive frame. That way the weight of the engine is pushing on the drive frame rather than the wood on top. And I'm hoping, and remember there'll be that rubber grommet between the drive frame and the wood. So I'm hoping to suppress some of that vibration. But we got a bunch to do. The motor's got to come off of there, the seat's got to come off. It's attached to the drive frame. I got to get some longer bolts. I got to get both wheels off. It's going to be a big project, and some of it will be fairly well summarized. Otherwise, I'd end up with a 10-hour video. Anyway, let's get started by taking the motor off. I kind of hesitate to get started on this thing because once I get started, I can no longer ride it, and I really enjoy riding it. I'll probably drive it around the neighborhood about, a couple times a week anyway. Who made this thing anyway? Everything's hard to get to. Oh, chain's still connected. Well, I've got all the taillight electrical disconnected and the brakes underneath. I had some redundant security measures here. I didn't want my axles sliding out because the set screw failed. So I had these collars on there as a backup. It'd be bad, axle sliding out while you're turning a corner. Even going straight would be pretty bad. Yeah. Well, it should pull out now. And it did. Good deal. There we go. Wow. Got it. That's where the sprocket set screw is digging into the axle. The space for the sprocket was really a lot narrower than I'd initially planned. It was just an oversight on my part, so it was only about 3/4 inch wide right there, and it just wasn't enough to handle the torque of the motor. Well, I need a break after that. It's a lot of work for this old vert. I'm going to regroup and then back with you in a few minutes. Okay, let's get this drive frame, if you want to call it that, metal frame underneath here off of here. Here's where I didn't have good planning when I designed this thing. I didn't anticipate, or I didn't account for, that flange, that locking flange to the axle. And by the time I put these in here, and look at the clearance I got there, just slight. The time I put that in there, that clearance there was too narrow for my sprocket. I mean, it worked, but I had trouble with the key wallowing out and getting loose. So, in the new design, this is going to get cut off right here, because my differential is going to go in there. Because this is a split axle and only one wheel drive, it had to be supported right here. One thing about these bearings I also didn't anticipate, they got a grease hole there. They're intended to be inserted and then pressurized to grease. And I didn't account for that. They're holding up good. I'm just going to take a chance on them. Well, there's no turning back now. Okay, I got those bearings locked down in the same place that they were when they were in the car. The left wheel was the drive wheel. See, those axles are just about touching right there. Now I've got to cut one of those axles off, probably both a little bit, and center that in there. And I'd like to get it perfect. It's going to be a challenge to do that. But they'll be keyed. Hopefully that key is the same size as the key in the bearing or close. If not, I'll cut it on the other side. But I'll drill the ends of the axles and put washers and screws on them to contain it within the differential. Okay, I've got a little bit of latitude here. The bearings are recessed 5/8 of an inch inside here. So I need an 1.25 inch gap here centered. So I'm going to cut this off about right there. And I'll probably have to go shorter with that. I know I will, because that's not 1.25 inches. But it looks about centered, so I'm going to cut that off. Well, this is kind of crude right here, but I've got some leeway on these axle positions, thankfully. This is actually the original buckboard flyer was 30-inch wheelbase. This one's actually 32. But it could be a little bit off from that 32. But I got the differential and sprocket centered. I got the bearings seated right where they were before, which is ideally what I want. I'm going to mark the end of this right here, and that's where I'm going to turn down to 25 millimeter from there on toward the center. These axles are 1 inch, and the bearings are 25 millimeter, which is, I think, 14 thousandths. So it's not going to really reduce the diameter by very much. I'll probably create a bearing fit right here, and turn down the middle just a couple of thousandths more. That way I won't have a tight fit all the way through to the other bearing when I insert the axle. Okay, this alignment is not super critical, but I want to get it as close as possible to the way it was originally. I've got the axle bearings locked to the axle in the exact same place they were, and they're seated. So I transferred the lines to this axle like this on each end. Then I measured in the bearing depth and put a mark on the axle on both ends. So now I'm going to put these collars on the axle so that the bearing sits up against the collar. And then I'm going to put a really strong scribe mark up against this collar so I'll have a reference. And after I machine it down appropriately to 25 millimeter, I will put this collar back on there and then put the shaft in the differential that I made and cut the other end of the shaft off to the appropriate length. A lot of work, but it's worthwhile taking the effort to get it right. This is really kind of risky here. Not risky, but not the right way to do it. It's not well supported. And I'm just making a groove about 8 thousandths deep, and that'll be slightly deeper than what I'm going to be turning the final diameter to. Like a 1/2 thousandths deeper. I don't know if I can do it or not, but I'm at least going to make a deep. That's probably deep enough. Now I'll do the same to the other axle. Now I'll take this collar off. And I can put my steady rest right there. If I need to, I can move the bearing too, but I really don't need to move the bearing. I can put my steady rest here, and I might have to move the steady rest here to cut this one too. Both like this fit. This has got to be a bearing fit, 25 thousandths here and here. I'll probably undercut that a couple of thousandths from 25. Okay, I got my the axle left over from the one I screwed up. And I'm going to use it to establish the right diameter. It should be 25 thousandths. I mean 25 millimeter. That's within about a couple thousand. That's probably good enough to set up my steady rest. Okay, I think that's pretty close. Okay, got the steady rest set up, and all I'm doing here is making a test axle for the bearing fit. I want to make sure and get this right. Plus 10, 75 plus 10, 85. Needs to be 84, so I'm really close. That's 84. That should be exactly right. Okay, now we can go for the real axle. Okay, part of this is going to be cut off right there, but that's still wide enough for that bearing fit. What I'm going to do now is take off between here and here, make it slightly smaller than the bearing fit. That way I don't have to force it over the entire length. So the bearing's going to be here and right here. It's going to be slightly under here. Well, I got one bearing fit right. Okay, I've put my locking collar back on here. I want to put this on here and then measure the shaft length, or mark the shaft length. See, it'll be the other way around. It doesn't matter. It's easier to mark like that. Okay, I'm going to make that about 30 seconds shy, and then bore it and put a screw and a washer on top of that. Now we're going to make a couple of washers. I guess you could call them retaining washers. They'll retain the axle in the Sprag differential. What I'm doing here is cutting out for the wider sprocket or sprocket assembly. I've got a guided bit here. It's got a bearing on the top, which is pretty convenient. And that plywood there will limit how far this router cuts. This is what I'm calling the drive frame. These come up and mount for mounting the motor. And I used these vibration mounts on the motor. And they're fairly firm, they're very firm. But which is what is needed, because when you accelerate, the chain would pull the motor down, and it gets slack in the chain. And I came up with a chain tensioner to help that. And it did alleviate the problem, but it's really tight, and I had to make this real narrow, and it's kind of weak. I'd like to do away with that. I don't know if I can. What I'm going to try to alleviate this problem is make this drive frame float underneath the wood. I enlarged one of the holes here, and I got these rubber grommets. Put them in here like that. And they're 5/16 instead of quarter. Anyway, I got 1/4-inch screws holding it, and I got this rivet nut, and I bored it out. It had 1/4-inch threads. So that's like a 5/16 to quarter adapter. That goes in there like that. That goes into there. And then this bolts to the wood. And I'm going to put this, which is not substantial enough, but I'm going to put it on the bottom, so it'll be sandwiched like that, and the wood will be right here. And I'm hoping most of the force will be downward, and this will probably be enough to let that drive frame move a little bit so it doesn't transfer the vibration to the car. Originally, I don't know if you watched some of the original video, I had a 5 horsepower Briggs & Stratton on there, and the vibration was horrendous. And somebody told me to get the Harbor Freight Predator motor, and it would be much smoother, and they were right, but it still had vibration. So anyway, what I'm going to do now is bore all these out for these grommets. Is a shallow key, not standard. So I went out on the internet and found this bearing, and it's 2 millimeters deep from the corners. Not from the radius, but from the corners. So I got and this is a 7 millimeter by 8 millimeter key. Don't ask me why it's 7 millimeter. Most keys are square as far as I know. But anyway, I've got to calculate the depth of the key slot in this axle here, and that's confusing to me. So I drew it in CAD, and there's what I did. There's the drawing I drew. The inside circle is the shaft that I'm going to mill the keyway in, and I drew a key slot representing the idea of that bearing right there, and converted it to inches, because that's what my mill does. And it's 0.223. That's the depth of this slot. If anybody knows a simple way to do that without some complex math, let me know. Otherwise, I'll just keep doing it in CAD. So I'm going to touch off at the outer diameter and then go down 0.22, what was it? 0.223. And this is my test. This is the test piece I made in the lathe, left over from the original axle one I screwed up. So I'll be able to test the fit. Okay, there I'm at. I'm just touching it. Everything's locked down. Breathe there on my knee and go up. 0.223. Okay, I'm 1,000. I'm gonna go a couple thousand. 0.22. Let's try that. Am I going too fast or what? That's a deep cut, but it should do it. What the hell? This is mild steel, and it's not cutting. Another new end mill that I bought a while back, and I have to retouch off, and I'll be sending that end mill back. Well, that's definitely loose. Got a piece of shim stock here. That's 30 thousandths, so I need to make it 30 thousandths more shallow. Okay, let's try this again. 22 thousandths minus 220 thousandths minus 30 is 19. 190 rather. I think some of that oscillation is due to that stick out right there. Okay, let's do it for real. Second burst, same as the first. The key fit good, so this should be might be a little bit tight, but I'd rather have it, I can grind the key down a little bit. Yeah, it's probably kind of hard to see there, but I'm milling down the key stock that goes in there to the width of the bearings. Well, let's put this together. Well, I've got to line these keyways up as best possible. Bearings turned. Getting those two bearings lined up is going to be a booger. Not as bad as I thought. Perfect, perfect again. Well, I think this came out pretty good. All my measuring and everything came out that far off. In other words, I can slip that this way a little bit. I was aiming to, these bearings are exactly the same place they were before I put in the Sprag differential. and I can loosen that set screw and move that in. My wheelbase will be off by that much. Won't hurt a thing. I like it. Okay, let's put this drive frame under the car. I've got a little micro switch under there. I gotta get around that obstacle when I install this thing. This whole drive frame is fairly heavy. I think it's probably over 50 pounds. A little awkward. It's working out pretty good though, I think. This one here will be for the seat support. So I just need 4 in the middle here. This is my engine mount. Kind of an interesting way I did this. I don't think it's necessarily the best way, but I put a taper on the end of that pin. And when I screw that in there, it's threaded into this piece. And if it ever gets loose, I can just tighten it up a little bit and it stops it from vibrating. What I like. Well, next step I think is to put the wheels on it and brake mechanism, and then make a motor mounting plate. This hole right here, I got to leave the bolt out until I get the wheels on, because the fender bracket mounts to that bolt. I just wanted to line it up. Looking good. Well, I might as well hook up these brakes while I'm down here. Let's put these fenders on and fender bracket. And I put an alamite on my fender bearings. I know that's kind of an unusual term, a finger bearing. And after I get it all put together, I'll lubricate that bearing via the alamite. That line right there is where the old motor was mounted, or the old, this is a replacement plate. The original plate that I mounted the motor was all the way to the limit this way, and I needed it to go a ½ inch further, so I'll put the motor, back motor mounts about right there. Just needed it for a reference. It was right there. Now I'm going to make it right there. Harbor Freight Predator motor, 212cc bolt pattern for mounting motor.
The Harbor Freight Predator 212cc engine uses a standard small block mounting pattern. The base measures about 162 millimeters, or 6.4 inches, long, and 75.5 to 80.5.
Got to make a brace across here with bolts going down to the, what I'm calling the drive frame underneath, same right here, and that'll be my tensioning mechanism. That way the pressure from the motor is on the drive frame and not the wood frame, and it'll let the, hopefully let the rubber grommets here absorb the vibration from the engine. That's the theory anyway. I don't know if it's going to work like that, but we'll find out. So I've got to position that and then weld it. First I need to cut this off. That motor was sitting crooked because it's hitting the torque converter. Need to cut that off right there. So we're going to put the torque converter on now. I got the chain on there. Did that off camera. These torque converters are pretty cool. Amazing they work. Okay, I got this thing up on blocks. It's not ready to drive yet. But I'm going to start it up and see if everything's, see what the vibration's like and see if the wheels drive right. Don't expect any problems, but I'd hate to get the seats on there. It's hard to get to the motor when the seats are on there, and I just soon find any problems now. wheels will coast forward, but not back. That was the idea of making that differential. Well, let's put the seats on and give this thing a spin. Well, it's nice to have the car functioning again. The improvements I made were a major improvement. The Sprag clutch helped with the steering issue under acceleration, although it didn't 100% cure it. I'm not sure why, but it's definitely better. It used to be one-wheel drive, and when I accelerated, you'd have to correct the steering because it'd shift the car one direction, and then when you'd let off the gas, you'd have to correct the other way. But it is better. So that's a good thing. One major improvement too was the rubber isolation mounts I put between the drive frame and the body. Huge difference. Vibration is much, much better. And then the most unexpected, well, I expected it, but it still surprised me, was when you were going down a hill and you let off the gas, the car gets quiet. Motor goes to an idle and you keep speeding up. You don't let off the accelerator and slow down. You have to put on the brake because the car now coasts. Let me show you. This is kind of interesting. Okay, watch that sprocket right there when I move the car forward. It doesn't turn. The car is now extremely easy to push. Of course, going in reverse, the sprocket is driven. There's some resistance. So it absolutely flies down a hill, and when you let off the gas, it does not slow down. Something I did off camera, I made a shroud. It had a plastic one on there to cover the torque converter. I like the metal a little better. Need something to decorate. I don't know, maybe some pinstriping or something. And then right there, something I did off camera too, was that's a little steel block that the screw sits in. It's sitting down on the drive frame. This is my motor tension adjustment. Chain tension adjustment. Got one on each side. Works really well. Of course, it's up against the drive frame, so the drive frame stays insulated from the car frame. Well, I still lack a few things. I got this bolt under here, a long bolt. It's hard to see, but got to cut it off, and got to hook up my electrical. My horn and headlights are not working right. Or disconnected right now. I disconnected them when I had the motor off the drive frame. But I'm gonna wait till it cools off outside and lift the front of the car. I got a lift outside. Right now it's about 90 degrees and pretty uncomfortable. Anyway, thanks for joining me. Be sure and subscribe and ring that bell.